Here we go. So looking at flight deck configurations, instruments, ICAS and ECAM systems, and how those have changed over time. And so what we'll start out with, just kind of a quick overview, the two most common configurations that are still out there today are, like I mentioned in the earlier lecture, having to do with types of transport category aircraft. The first one is 3 crew aircraft. We have a captain in the left seat, a first officer in the right seat, and a flight engineer, or also known as a second officer, is at a flight engineer's panel. And usually that's located somewhere behind the captain and first officer, kind of off to the side. In the last 20 years, give or take, the 3 crew flight deck has been kind of replaced by the 2 crew flight deck, and we'll talk about why that was and how it happened. But in this case, now you have a captain in the left seat, a first officer in the right, and the flight engineer or second officer position has been eliminated entirely. A lot of these aircraft still have what are called jump seats. Actually, all of them do. They're required to have at least one jump seat, which is not a crew member, but it's another seat in the flight deck. And the reason they're required to have at least one jump seat is flight crews, and commercial operators, transport and things like that, commercial pilots, have to regularly have what's called a check ride on a regular basis, and they have to have a examiner from, at the minimum, from the FAA, but also typically they do company check rides as well. Where a very experienced pilot rides along and evaluates their performance on the job. Their flight crews don't ever fly empty airplanes unless it's for like repositioning or flight testing. For training purposes, they do most of their training in a simulator, and the full motion simulators that they have for airlines and cargo operators and that kind of thing to use are absolutely amazing inside. The fidelity of them and how realistic they look. And so when the first time a flight crew on a commercial aircraft, transport category aircraft, the first time they fly an actual airplane, there are going to be passengers in the seats or cargo loaded or whatnot. But they do have to have the check ride. So that extra seat, that jump seat, they're not considered crew members, but they are in the flight deck. The 727 has 2 jump seats. Most of your regional aircraft have a single jump seat, but they have to have a minimum of 1 to allow for that. There were aircraft, and you don't see these at all really anymore, that did use a 4 crew configuration, and we really don't worry about that too much anymore. But essentially what you had at that point was it was a 3 crew. You had the captain, the first officer, and the flight engineer. But then you had someone who was in charge who had to do navigation and communication. So they basically worked the radio systems in the aircraft. And that was the first position in the flight deck to be phased out. The radio work was moved to the captain and first officer. Navigation was moved to that, and those were all also some of the first things that were automated and allowed that with what's called an FMS, a flight management system that can interface with the navigation instruments to know where the airplane is and where it needs to go. They interface with autopilots to direct the autopilots, and they can interface with the communications equipment to be able to bring up different radio, comm channels and ADF and nav, radio tuning and all that stuff. So that was all done and eliminated that 4 crew. So everything we see today that's still flying is pretty much in the 3 or more and more commonly 2 crew configuration. So here's an example of 2 flight decks that are on similar aircraft. Let's see, the 727 on the left. You've all been in our 727, should be pretty familiar. So you have your pilot, your captain, your first officer, your flight engineer panel. And then this right here in the very corner is the tip of a jump seat. the jump seat, those extra seats I was talking about. This one's a little cleaner than ours. And then an example of kind of an earlier two crew is the Boeing 767. So you can see this has an earlier ICAS system in it, flat panel displays, but these are cathode ray tubes. They are old style television screens. But there is no flight engineer back here. So what drove this transition? And the biggest thing that allowed for it to happen was technology. So what drove it and what allowed for it are kind of two different things. But technology allowed for it. What we did is the complexity of operating the aircraft, not the complexity of the aircraft itself. They're still very complex. In fact, you would argue they're more complex than they were back when they were two crew or three crew aircraft. But the complexity of operation was reduced by engineering tasks out and essentially automating things, automating things like monitoring of systems. Whereas on an aircraft like the 727, the flight engineer has different indications, gauges, and whatnot on their flight engineer's panel that they have to do a scan. They have to, during flight, they're going to look over their panel in a prescribed manner over and over and over again to look for anything that might be abnormal. And going to, with technology and computerization and that kind of thing, now we can automate that where as long as things are working like they should, no one really needs to be constantly looking at it or scanning it. But if something goes wrong, we need the attention of the flight crew to be brought to that. And so modern systems are able to do that. And so that's one of the ways we did it. Once we did that, once we proved that this technology could essentially do the job that a third person used to do, the regulations surrounding the aircraft and the design of them and operations and that kind of thing, those regulations were changed then to allow a two crew aircraft. And that was a big deal to make those changes. Part of it was the fact that they wanted to make sure it was safe. It had to be proved safe. It had to be proved reliable. The other side of it is there was a political aspect to it, and that is the pilot unions and the flight engineers did not want to lose their jobs, and so they really tried to prevent aircraft from going from three crew to two crew. And in all likelihood, and probably my lifetime and definitely in your lifetime, it's possible that aircraft are going to go from a two crew to a single crew. Or even, some people talk about drone technology. I personally don't see people being comfortable getting on an aircraft that doesn't have at least one person in there, but I imagine it won't be uncommon to have a single flight crew member with the ability to have the airplane flown remotely as well in a single crew configuration, but still have somebody on board that can kind of do the critical thinking if something goes wrong. Or have someone that can do on a long haul flight can monitor and fly the airplane out of, say, New York, and then be able to take a nap while the airplane is flown remotely over the ocean, and then that crew member then comes back in and handles the landing or the final leg of the flight into, say, London Heathrow. So you'll probably see that kind of thing, but I can tell you, knowing people in the industry, the pilot unions are going to not be super receptive to that, because what it means is you need less pilots to do the job. From an airline perspective, an operator perspective, a cargo operator perspective, what does this mean? It means the big thing is we save on salaries, right? You don't have to pay people if you can reduce the number of people in the flight deck. It reduces space. Now you can make that flight deck smaller and have more room for passengers or cargo. It reduces weight. You miniaturize the electronics and make them smaller. You get rid of the weight, and weight reduction also allows for additional people or cargo. It also makes the airplane more fuel efficient because you don't get the induced drag that's a result of extra weight. It reduces the amount of training. You have less people you have to train, and with more things being automated, the training can focus more on rather than the day-to-day flying, but more on dealing with abnormal situations, and it goes on from there. So, you see this drive, and it's definitely happening. In terms of design philosophy, with the two big names in large commercial aircraft, Boeing versus Airbus, they do have slightly different design philosophies, and this is shown in kind of the setup of the flight deck as well as how some of the systems work on board the aircraft. And so what I mean by that is that Boeing tends to provide the flight crew with more raw information and more direct control of systems, whereas Airbus tends to give more interpreted information or processed information to the flight crew. And then they also build in certain, the inputs that the flight crew make also are processed before they go to the aircraft. And what I mean by that, the example is in flight controls. Boeing's are more, they stuck with a traditional flight control system for a lot longer than Airbus, where you have cables, or you have your flight control, your yoke is connected by cables, pulleys, bell cranks, whatnot, to the hydraulic control units that control the flight controls, and direct inputs move valves on the flight control actuators to move the actuators for the hydraulic fluid. Whereas Airbus went to a fly-by-wire system much earlier, and those fly-by-wire systems, when we get into flight controls, we'll talk about what are known as envelopes and control modes, where the normal control mode for an Airbus versus a Boeing, for instance, is if a Boeing pilot pulls back on the column to bring the nose of the airplane up, the airplane will continue to go up and up and up and up until it stalls with little protection. And they rely on the flight crew to understand or know the limitations of the aircraft more. The Airbus A319, 320, 321 family, however, the flight control envelopes is if the flight crew grabs, and I remember I said they have a sight stick, and this is a rendering, by the way. This is not the actual cockpit, but it was a clearer view. Most of the ones I could find had flight crew members sitting in the way. I wanted one where it wasn't. But if you grab the side stick and the flight crew pulls back on this fly-by-wire system, that fly-by-wire system, that flight control system, is integrated with the angle of attack indicator. And I should go back to the Boeing for a second. So you pull back, the airplane's going to stall. The flight crew will get a stick shaker telling them that the airplane's going to stall, but they can continue to pull back and continue to climb until they put the airplane into a stall. The Airbus, on the other hand, if they pull back on that side stick and they keep pulling back, you can pull that side stick all the way back. And what that's going to do, the normal flight envelope in an Airbus fly-by-wire aircraft, is when you pull that stick back, what you're essentially telling it is you want to climb as fast as we can, but not stall the airplane. And so you can pull back on that stick as hard as you want under normal control mode, and the airplane will pitch nose up until it gets to just before it would stall. And then the fly-by-wire system and the AOA vanes and everything are going to hold the airplane, and the auto throttle, the engine thrust level, are going to hold the airplane at that nose up just below a stall. It's not going to allow the airplane to fly into a stall. Okay, so they have this slightly different philosophy. One is One is you're getting the raw information, fly the airplane. The other one is you're kind of directing the airplane, but it kind of knows its limits. Other things you see have to deal with like the way they do panels. So this is looking at the 737. This is a newer 737. Even the 730, this is I believe a 737. It's in the 67800 family. It might, I don't think it's a MAX. But versus the Airbus A321, which is a similar vintage aircraft, you can see Boeing still looks like a bit of an older panel. Airbus is more schematic and push button switches. So for instance, you have panels based on, here's hydraulic systems. You can see this, the left hydraulic system runs off the number. So you got engine 1, engine 2, and APU fire at the top. Engine 1 runs this side of the hydraulic system. Engine 2 runs the right side of the hydraulic system. The APU is able to run part of the hydraulic system. Then you go down into fuel. Here's the fuel feed for the left engine, the fuel feed for the right engine, APU fuel feed. Now you can cross feed. You can open the valve. This is a valve in the middle to be able to bring fuel from the left tank over to the right engine or vice versa. Boeing allows you to do this in a similar manner, but it's not quite set up like that. This is more, so these are laid out where, you have hydraulics, fuel, electrical, air conditioning kind of in rows, and then in everything that kind of ties to engine 1's on the left here, everything that ties to engine 2's on the right, and everything, kind of APU or cross feed, cross bleed controls are in the middle. Boeing tends to lay stuff out by system. So here's your flight control system, navigation. I want to say this is fuel, if I remember right. Okay, and it is still left, left boost pumps, right boost pumps, center boost pumps, and then fuel feed to your engines. You have pneumatics over here, so left bleed valves, right bleed valves, left pack, right pack, air conditioning. You have an electrical, so it is still laid out in a bit of a schematic form, but they're panels kind of by system, rather than here they are by system, but they kind of put them into like a grid by system and engine that primarily ties to that system or that part of the system. So what they call this is Boeing is a systematic layout where the pilots are given pretty wide controllability, where they get kind of more raw information, the standard yoke with less limits on it. Airbus is more functional, schematic-based layout, how it ties to everything. They tend to automate more, and they go on a less is more philosophy. Kind of their idea is we don't want to throw too much at the flight crew. And then they use a side stick fly-by-wire. Okay, so these those. And the other manufacturers kind of fall in similar categories. I would almost say, from my experience, that CRJ Canadair products, the CRJ 200s, and then and now that it's A220, it's a little different. That was more Boeing design philosophy. The Embraers are a lot more similar to Airbus, although, excuse me, the A220, the A220, which was a C series, that kind of went more towards the Airbus kind of design. That's maybe the French Canadian influence getting in there. So you'll see both of those, but that's kind of their biggest differences with operation. Pilots, depending on who you talk to, flight crew operators, and even maintenance technicians, you'll get mixed bags. Some people are really like the Boeing. They want to see that raw stuff. They want to be able to control everything. Others like the Airbus better. Like, I want the airplane to be more simple to fly. I want the airplane to be able to kind of look out for itself, so to speak. So, depending on who you talk to, there's a rivalry. Both make very safe airplanes. Both make fully functional airplanes. They obviously have hiccups, but in the end, they there's nothing bad about either style. So when we look at the flight deck philosophy, the design philosophy, there's a few things that we want to look at. One of the things that you see more and more of, and this applies to flight deck. It's also applying to maintenance processes, because we've noticed that um, if a flight deck isn't comfortable to operate, if a maintenance task isn't comfortable to do, it's not going to be done well. People are going to try to find shortcuts or find ways to change it up. And what that leads to is errors and leads to things being done improperly. And so the flight deck design philosophy, but now also including maintenance, maintainability design, is looking very heavily at ergonomics. And so understanding how a workplace and the equipment can be best designed for comfort, safety, efficiency, and productivity. And all of those can directly translate into economic gain for the operator. And taking into account anthropometry, science of measuring humans, knowing that people aren't all equal in terms of body dimensions, sizes, length of arms and limbs, that stuff. And so we're looking at this kind of stuff as we look at maintenance, as we look at designing flight decks and aircraft. So when we're designing it, one of the big things is looking at eye level and knowing what the eye datum is. We want everyone sitting in a flight deck to have the same view, and we need to understand that. The reason this is important for maintenance technicians is many of you are going to operate the aircraft from a standpoint that maybe you won't fly it, but you'll definitely taxi it. You'll need to move it from the gate to the hangar to the, from gate to gate, whatnot. So when you get into an aircraft, you look for the eye datum. So this little set of the three balls right here are used to figure out if you're sitting in the right spot. And so what happens is, if you are sitting in the captain's seat or the pilot seat, the left seat, when your head is in a proper spot, if you look at this front ball right here, this one should be right behind it. Okay, you'll be looking from an angle over here, and this should be right behind it if you adjust your seat correctly. Consequently, if you're sitting in the right seat, you're looking at this front ball right here. This ball off to the left should be directly behind it. So when you get into a flight deck, if you're trying to figure out if you're in the right spot, if you have your seat adjusted correctly, you can use the eye position indicator to figure that out. And at the same time, once you do that, then it should also put most of your critical controls within reach. I wouldn't say easy reach for everybody, because some flight decks are small, and someone like me, some stuff might be too close. Or you get into a larger flight deck and somebody who's smaller may still have to lean over and reach, but we try to make it as best as possible for the most number of people. So when the cockpits are designed, or the flight decks are designed, when you're getting in there and trying to find things, understand that there typically is a logical layout for controls, and most of the time they kind of go in this order. So logical layout is laying stuff out in a manner that things are say in a schematic, like I was showing. There are kind of those schematic diagrams on the overheads where it shows the different valve positions and the lines going from valve to valve, or electrical bus to electrical bus. Is it connect to the left or the right engine, kind of like the Airbus setup? Frequency of use, things that are more common to be used are put directly in front or just off to each side. Things you're turning on, getting ready to go, are on that overhead panel, but you're probably not going to be doing too much operating of them in flight. Radios tend to be down in the middle where they're easy to get to, but again, you're not operating them all the time. Circuit breaker panels a lot of times are behind you or down by your feet. You're rarely going to the circuit breaker panel, but it's there if you need it. So frequency use, tactile, things are going to be shaped certain ways, right? Certain shaped switches or things like that. And then standardization. How about, what, we're going to leave off today. I'll pick this up next time. So let me get the attendance poll going. And if anyone has any